In this video, I will show you how you can make a totem pole PFC bidirectional so that it flows in both directions. So due to those diodes, that is not possible. So first, I will just show you that this works. So basically what I've done, I have a current reference, which is sinusoidal. I just predefined that. And then if you look at the signals, you can see that the current is controlled. And we also have stable voltage and a sinusoidal input voltage. So the first thing that we want to do is to remove this and replace it with a DC source. Because if it runs in the opposite direction, the current has to come somewhere. And that is from the source. So we can just add that. And I will call this V out, which is what we've defined as the DC voltage. So if we now run it again, you can see that we get exactly the same result, except for now the output voltage is constant. Now the next thing we want to do is to remove these diodes, because we don't want diodes anymore. We want some switches. So we can actually just replace these and the simulation will still run. We will still get the same results. So actually, this is the topology of the bidirectional totem pole PFC. But in order to make it flow in the other direction, we need to control these as well. These switches are called the slow leg because they switch with the input voltage. So I'll just add some switches here. I will call them S3 and then S4. So S3 and S4. And we can add some inputs for these. So here we have one for S4 and one for S3. And then these needs to be opposite for it to make sense. Because if they're not opposite, we would short circuit the DC link. So I'll just draw like this. Now these switches are only dependent on the grid voltage or the AC voltage. So basically when the voltage is positive, this one should be turned on. And when the voltage is negative, this voltage should be turned on. I will just first implement it and then I can explain later. So in order to make this happen, we have the voltage, which is here. And then we need a comparator to know when it's 0 and not 0. Now it's called a relational operator. So we just insert the voltage into the lower input. And then this input is 0. We can actually just add a constant, which is 0. Now, if we try to run it again, you will see that we get exactly the same results as earlier. But now, the only difference is that we have a spike when the voltage crosses 0. And this is natural. This happens because we don't switch when the current switches, we switch when the voltage switches. And there is some ripple around the 0 crossing, so we're not able to switch at the right point. But that is okay. So if we change, now this should work as a bidirectional totem pole PFC. So if we change the phase of the current, let's say that it is negative pi, so now it's in the opposite direction. We can try to run it. And you'll see that the current flows in the other direction now, while everything else is basically the same. And we can also run with full reactive power. So pi halves, that would be reactive power. So now the current and the voltage is not in phase. They are 90 degrees shifted from each other. Then we have pure reactive power. So that is how you can make a bidirectional totem pole PFC in Simulink. And in my next video, I'll explain why you switch the slow legs with the voltage and not the current or anything else. I will also go more into detail on how the bidirectional totem pole PFC works.